obvious.
Gradually get it out.
Alright, so we're going to do proofs for a little while. And a proof is not like it was in geometry so much. Because you're, well, but in a way it is. Okay, so.
Yeah, I don't know.
Oh my Lanta. You want to prove that to be true.
Oh my Lanta.
Okay. Alright, so here's how a proof works. You only get to manipulate one side, is kind of the rule. And I don't know why that's the rule, but it is the rule. So we're supposed to pick like one side of this and manipulate it however we think would be best. And we're supposed to magically get what's on the other side. These should be pretty simple, because the only thing you have so far is like Pythagorean identities and even odd stuff. And you know that like tangent is sine over cosine and stuff like that. So eventually these will get more difficult because we're going to have new identities that you don't even know yet. Mine's going to be alone. But if you had to do a proof like this, what I do is pick whatever side seems more complicated and work with that. Like for example, if I pick this side, what is secant times cosecant, by the way? 1 over sine times 1 over cosine. That's not going to, like, if I just think about it in my head, I don't see that leading me back to here real easily. So I'm going to take that left-hand side, because what could I do with that?
Sine over cosine.
Yeah, I can, like, make this sine over cosine.
Yeah, what I'm saying.
And make this cosine over sine. And then, what might I do if I have a fraction that's not together? Common denominator. So I would say this is cosine x times sine x. I always confuse people when I make common denominators. I think we talked about this before. So like, if this one needs a sine, then I'm going to multiply by sine over sine, just this guy. Okay, so again, this is not like, even though this is an equation, I'm not working with both sides of it at once. I'm only working with one side at a time. So if I want this fraction to be a sine cosine on the bottom, I multiply by sine over sine, so I get sine squared. And then this, if I want it to be sine cosine on the bottom, what do I multiply by?
Cosine.
Cosine. So I get, whoops, cosine squared x, and then what is the top of that? 1. Oh my god. And then I kind of have to pull this back apart. If I have 1 over cosine x sine x, since it's multiplication, you don't need to write this as a step, but this is the same thing as both over 1 or both under 1 multiplied. It's all multiplication, so like that's all stuck together. So what's 1 over cosine times 1 over sine?
It's secant times
Secant times cosecant. And that's enough. I don't have to go, oh, I do have it in the same order. If I had written cosecant, secant, that would be fine. Once you get the one side to match the other, you did it. And that's it. It's going to be pretty simple. Sometimes at the end of the proof you see the letters QED. Have you ever seen it before?
No.
It's like Latin for like, I proved it. It's like Latin for in your face.
What does it stand for?
Is that what you want me to write in my notes?
I do.
All right.
Latin for, this is Latin, goes back to 200 BC for in your dirty face.
Wait, what is it really stand for?
I don't know. It stands for something that we've looked up before. I've looked it up before.
What does it mean then?
It means like I'm done. Or no, at the end it means like it is proven, like it is so. Huh, I'll check.
It is so.
It is so in your face.
Dirty face.
Dirty face. Let me see, I have a handy dandy iPhone. Have you guys ever heard of these things?
Yeah, man.
No, I still need to get one.
QED.
Yeah, man.
There we go, on Wikipedia. QED is an initialism of the Latin phrase quod erat demonstratum, which means
It was demonstrated.
the phrase is traditionally placed in its abbreviated form at the end of a
Which was
mathematical
demonstrated.
proof. And it is just stated as a conclusion of the demonstration. I'll put it up. So it stands for quad
Quite easily.
erat.
That'd be like quod, not quad.
Yeah.
I don't know how to pronounce it. What do you think I take Latin? this all the time.
Doesn't that be
We always ended proofs like that, and so did our professors, QED. I always thought they were drunk, and then I realized it actually stands for something in Latin. I'm really sorry.
Wait, so you don't know what it actually means?
Yeah, I just said. Okay. Originating from the Greek analogous something, meaning which had to be demonstrated. That's what it says in quotes.
It should be which was demonstrated.
Which had to be demonstrated. At the end of a mathematical proof or philosophical argument, when what was specified in the enunciation and in the setting out has been exactly restated as a conclusion of the demonstration. It's proof. So, there you go, QED. If you want to add some expletives, you go ahead.
That's inappropriate.
Oh, right.
Don't try this at home, kids.
Alright, so here's another one, just to kind of get the hang of it. Let's do... Let's do this one. Alright, sorry, I'm just gonna think. Okay, so what people get frustrated with is it's kind of like if you could only cross multiply,
You can.
but you can't. Because if you could cross multiply, it'd be so perfect. This side would be cosine squared. This would be 1 plus or 1 minus sine squared, which in the Pythagorean identities thing is cosine squared. So you'd be set. But that's not how you're supposed to handle it. So this is just trying to teach you.
What do you mean supposed?
It's trying to teach you how to like just think about trig differently to make sure you understand all the identities and stuff like that. So if you can't cross multiply, this problem is really annoying because you can't really reduce either side.
Yeah, you can. 1 minus sine x is cosine, isn't it?
No. 1 minus sine x is cosine?
Oh,
It's gotta be
not squared,
squared.
okay.
Right, since it's not squared, we're really stuck.
Common denominator.
You can't square both sides
Common
because that's doing something to
denominator.
each side. Even common denominator, like they already have common denominators separately.
Oh wait, I know.
Why don't you
It's not true.
split apart just one over cosine?
That would be the only thing that you could do is like this does split. I just don't know if it's going to get you anywhere. Remember, if your denominator is one term, I can make this 1 over cosine x plus tan x.
There you go, that's gonna work.
But I don't think it's going to get you because even this, then that's just like
No,
secant.
but it's gonna work. But if you do the other side, can you only do one side?
We're
And then-
supposed to only manipulate one side.
Why?
It's kind of like the rules. Now, if this was real life and we were actually trying to prove something, like in the real, like that hadn't been proven before, we could manipulate both sides.
Wait, are you really gonna get that to look exactly like that?
That's the plan.
I just don't get the purpose of it.
But it doesn't work out, so trick,
Yeah, that
trick
one
question,
doesn't.
everybody.
You can't do that one, can you?
No, I think it does work.
Trick question, everybody. What up?
I think it actually works.
Okay.
So ready?
She's gonna pull something out.
I am
We're
gonna
all
pull something right out of my butt,
And we're
and
gonna be.
it's
not another trig identity,
gonna
is
be
it?
really ugly. No. So you know how in math, like, there's all these like little tricks that you know, and you take them as, like, you take it for granted. Like you know how to factor, right? And you
No.
take that for granted that you know how to factor. You do. And like if I had a fraction, you know how to make a common denominator. It's just something that you do. You're really good at it. You do it quickly. But there's something that we use so infrequently, you don't think of it as an option. But when proofs come up, it's actually a viable option, and it's called multiplying by a conjugate. Remember back in the
What the
day,
heck's a
you had
conjugate?
like 1 plus root 2 as a fraction. You wanted to get rid of the square root. You could multiply by this.
Oh.
Multiply by
the
its
Erm
and it
Erm.
would get rid of that square root on the bottom for you. It was called multiplying by a conjugate, not because it had roots. And that's what, when people think about multiplying by a conjugate, they think about that has to have a connection with square roots, but it doesn't. The thing that made it a conjugate was instead of the plus, it was a minus. That's what made it a conjugate. Not anything to do with roots. It just so happens to help us in square root problems. So if I take this side and I multiply by 1 plus sine x, it just might be the trick I need to make
Did you
it
know
work.
that the whole time?
Did I know it?
Yeah.
Then why did you say that?
Yeah, and start making us feel dumb.
The same reason I need to teach my kid how to wipe his butt. I can't just...
What's the reason?
I can't just do it for him all the time. I have to teach him how to do it. Teach a man to fish. Oh, no, what is it? Give a guy a fish. Give a guy a fish.
Feed him for a day.
Feed him
Teach
for
a
a
man
day.
to fish.
Teach a man to fish. Get
Feed
him
him.
frustrated and make his wife leave him.
That is not what the saying is.
You know when guys go fishing, their wives get annoyed. You go fishing again, honey. And so they get divorced.
That is awful.
Then why are you
Not get
teaching
that
us how to
from
fish
that.
if our wives are just gonna divorce us?
Yeah, for real. For real though.
So,
Obviously, this could end in tragedy.
Wait, but
no.
so on the top, I would like potentially distribute. I don't know if I will yet. I don't always distribute right away if I don't know if it's going to help me. So I'm going to leave it like that for just a second and just see if that's something that's going to help me or not. But on the bottom, what do you get if I multiply those out?
1
minus
sine
sine.
squared.
I get 1 minus sine squared, and now I've got a squared. And that was really helpful because what is 1 minus sine squared?
This is
Cosine.
weird.
Sine. And then what happens to the cosines?
One of them cancels, but one of them still
One of them
stays.
cancels, so I've got 1 plus sine x on the top, and I've got cosine x on the bottom. And QED, I am done.
Do we have to draw the arrow?
No. I just get excited. So like, you're gonna have some strategies. One is get a common denominator, see what happens. One is take, if it's tangent or secant or cosecant, take it apart, split it up into sines and cosines and see what happens.
One is get frustrated and realize it doesn't work.
One is get frustrated, but spend 20 minutes anyway, because that is what we all are aiming to do. So these proofs, you might end up hitting a dead end, and then you have to go try something else and start over.
Oh my
There's
god.
no reason, like, I usually try to start with the more complicated side.
See, that
This isn't more
happens in
complicated
that
necessarily than this. How would you judge which is more complicated?
Because you're late.
So I think starting with this side was totally logical.
Right.
It just didn't get you anywhere. So you got stuck. And once you get stuck, you usually have to start over. We can stop there.
Stop it.
We can just tomorrow, I know, right? Like we only
You
did two.
should.
But tomorrow
See what
we'll
he
just do
thinks.
the problems. Just have to try a few and make sure you're good. And then Wednesday we'll do sum and difference identities, and that'll be all.